Sam, if we weren't, you were here, you could do this, and it'll come out a lot better than me doing it. You're on a well-deserved vacation, and we are certainly cool with that. I will do my best to try to do this justice. Sam could never get the audio to come up when he wanted, and some of the other quirks, trying to use PowerPoint to do a lot of things is sometimes more trouble than it's worth. Anyway, I'm going to try to do this justice, so please bear with me. Hi, I'm Tom Hurley. I'm filling in today for my good friend and colleague Sam Rose of South Placer MUD, and I'm going to be playing designated hitter today as I try to take on this presentation. So welcome to Collection System Math, Determining Slope. To start off here, you have to be familiar with two terms, rise and run. The rise is shown here on the right. It represents the elevation difference between the inverts of these two manholes. The run is the horizontal difference between those same two manholes. This should be pretty cut and dry here. Okay, so the rise is vertical, and the rise is the increase or the change in elevation. The elevation, of course, is relative to sea level, and the sea level in this particular case is 0 feet. The run, it's the horizontal. So the rise is on the right, and it's the difference between the invert elevations of the two manholes, and the run is the distance between the two. So let's talk here for a second about the vertical drop here shown in this graphic. The difference here basically is a gravity line, and the vertical drop is the distance in elevation between the two manholes. Gravity, of course, is required to move flows, and that's one of the reasons why we're doing this calculation. So as flows move from one manhole to the next, they have to have a certain amount of percentage to move solids and liquids. You'll note at the manhole on the right, it has an elevation of somewhere around 20 feet. The downstream manhole, it's sitting at somewhere around 15 feet maybe. Either way, we know that we've got some kind of a drop here. We're going to go ahead and plug in an actual number here in a second. So since we know that the run is 327 feet and the other invert elevation is 318.7 feet, the invert elevations are 318.7 feet for the downstream elevation, 322.1 feet for the upstream elevation. We know that in order to establish what the slope is in percentage, that we have to plug in a formula. And the formula here is the rise divided by the run. Let me repeat that. The formula is the rise divided by the run. On the top, it shows the vertical difference. On the bottom, it shows the horizontal. Again, the run is 327 feet. The upstream invert elevation is 322.1 feet. The downstream invert elevation is 318.7 feet. So our unknown really is what is the rise, and then ultimately what is our percentage of slope. So to get there, we're going to use the two invert elevations to determine the rise. This is fairly simple. We're going to subtract the 322.1 feet minus 318.7 feet. You should come up with 3.4 feet as being the difference. Let me say it again. 3.4 feet is the rise. And that is the difference between the elevation of those two manholes. There it is, 3.4 feet. Let's move on. So start by recalling that we now have established the rise as 3.4 feet. We're going to now divide that by taking the run, which is 327 feet, and we know that we're going to have to try to solve for slope dividing the rise by the run. So that's 3.4 feet, the rise, divided by the run, 327 feet. That should give you an answer of 0.010. Now, if that doesn't sound like a percentage, there's a reason for it. We still got another step left here. You've got an answer here, but it's only in decimal form. It's not real complicated here. The only step we have left here is converting that decimal to a percentage. To do that, you simply convert a decimal to a percent. And you do that by multiplying that decimal times 100. That will move the decimal point 2 places to the right and will bring you to an answer of 1%. And that's the lesson. Determining slope with Sam Rose and Tom Hurley. Thank you.